At this very moment, while you're absorbed in these words, approximately 200 billion trillion suns blaze throughout the cosmos we can observe. Every single one of these stellar furnaces burns with unimaginable fury across the void, and countless numbers host planetary systems where life might flourish. Given such staggering quantities, our universe ought to overflow with advanced beings. Massive alien metropolises should sprawl across distant worlds. Our detection equipment should capture transmissions from thousands of distinct species broadcasting into space. The darkness above should shimmer with artificial illumination from innumerable technological societies. Yet we encounter nothing but silence. Tonight we venture into perhaps the most chilling theory in scientific exploration, a hypothesis suggesting humanity could be experiencing its ultimate phase without any awareness. This cosmic nightmare scenario demands our immediate attention, and understanding it might determine whether our species has any tomorrow at all. The tale unfolds during a sweltering afternoon in 1950 at Los Alamos National Laboratory in New Mexico's desert landscape. Four extraordinary physicists stroll toward their midday meal, engaged in animated discussion about flying saucers and the mysterious aerial phenomena generating newspaper headlines nationwide. Their conversation flows casually, almost jovially, as these scientific giants speculate about interstellar travel possibilities and extraterrestrial encounters. Settling into cafeteria chairs, one brilliant mind suddenly grows contemplative. His thoughts drift beyond light-hearted speculation towards something infinitely more profound. Mathematical concepts cascade through his consciousness. 200 billion stellar bodies within our galaxy's boundaries alone. Eons of cosmic development stretching back through time. Unlimited opportunities for biological emergence, advancement and galactic expansion. Abruptly, Enrico Fermi raises his eyes toward his companions and voices an inquiry destined to torment humanity for generations ahead. Where are they? These three elementary words encapsulate arguably the most bewildering enigma our species has confronted. Considering the universe's immense proportions and the nearly unfathomable duration since creation's explosive beginning, intelligent existence should manifest not merely as possibility, but inevitability, commonplace throughout space. Evidence of alien society should surround us completely. Our radio detection arrays should intercept their communications continuously. Our exploratory vessels should discover their technological remnants scattered across solar systems. Our very existence demonstrates that consciousness can develop within this cosmic framework. Why, then, do we detect absolutely no signs of it elsewhere? This fundamental question evolved into what scientists recognize as the Fermi paradox, and across 7 decades, researchers have grappled with its profound ramifications. Every proposed solution generates additional mysteries, more disturbing possibilities regarding existence and intelligence throughout our cosmos. However, in 1996, economist Robin Hanson formulated an explanation so unsettling it revolutionized our understanding of humanity's prospects. Working from his position at Oxford University's Future of Humanity Institute, Hanson unveiled a concept he termed the Great Filter. His framework possessed elegant simplicity while carrying absolutely terrifying consequences for every living being. The Great Filter proposes that somewhere along evolution's pathway from lifeless matter towards spacefaring civilizations exists an obstacle so insurmountable that virtually no species successfully navigates beyond it. Envision this as a cosmic barrier that eliminates nearly all potential life forms, rendering the universe predominantly empty and eerily quiet. This filter might rest behind us, explaining the absence of detectable aliens throughout the vast expanse. Alternatively, it could await us ahead, preparing to eliminate our civilization precisely as it has destroyed countless predecessors before us. Nothing could carry higher stakes for humanity's survival. Should the Great Filter exist in our past, then we rank among the incredibly fortunate minority who somehow overcame impossible statistical odds. We represent cosmic lottery victors, remarkable anomalies who managed to develop intelligence within a universe where such development occurs extraordinarily rarely. But if the Great Filter lies ahead in our future, we advance blindly toward inevitable extinction. Each technological breakthrough, every forward step in our species' development, brings us nearer to an invisible boundary that has halted every other civilization attempting to cross its threshold. Determining which scenario confronts us requires tracing the evolutionary journey that brought us to this critical moment. Hansen identified 9 essential stages any species must successfully navigate to achieve what he labeled explosive lasting life, the capacity to spread throughout the galaxy and establish permanent presence among distant stars. This journey commences with the fundamental requirement: locating the appropriate stellar system. Not every star suffices for life's emergence. The cosmic neighborhood must contain proper concentrations of heavy elements forged within previous stellar generations' cores: carbon, oxygen, nitrogen, phosphorus, minuscule complex chemistry's building blocks must exist in adequate quantities for biological processes to commence. The host star itself demands stability, burning consistently across billions of years without violent eruptions and fluctuations that would sterilize nearby planetary bodies. Beyond stellar requirements comes planetary necessity. Any world supporting life must orbit within the narrow habitable zone permitting liquid water's surface existence. Excessive proximity to its star causes water to vaporize into space. Excessive distance freezes water into solid ice, imprisoning one of life's most crucial components. Suitable planets require appropriate mass for atmospheric retention, adequate magnetic fields, deflecting lethal cosmic radiation, and likely proper lunar companions stabilizing rotational patterns while generating tidal forces potentially vital for early biological development. These prerequisites might sound reasonable until mathematical analysis begins. Among thousands of discovered exoplanets, only minute fractions satisfy all requirements simultaneously. Most orbit excessively close or distant from their stellar parents, lacking the delicate balance necessary for liquid water's persistence across geological timescales that complex life demands for emergence and development. The sobering reality becomes clear. Even reaching the first step toward galactic civilization requires navigating odds so astronomical that perhaps we should marvel at our own existence rather than wonder about absent neighbors. Yet this represents merely the beginning of an increasingly treacherous journey ahead. Most planetary systems harbor red dwarf companions that continuously assault their worlds with lethal radiation bursts. Additional candidates lack steady environmental conditions, essential for billions of years of uninterrupted biological development. However, let's imagine we've triumphed in this initial cosmic gamble. We possess the ideal stellar furnace, the flawless world, every necessary component floating within warm oceanic expanses beneath a shielding atmospheric blanket. The subsequent challenge emerges as our second evolutionary milestone: spontaneous generation of self-copying molecular structures. Here mysteries deepen dramatically. Within Earth's ancient chemical broth, lifeless substances will somehow arrange themselves into the universe's first reproducing molecular systems. This phenomenon, termed abiogenesis, marks one of existence's most extraordinary transformations, the precise instant when inert matter initially achieved living status. Researchers have spent countless decades attempting to duplicate this moment within controlled laboratory environments. The groundbreaking Miller-Urey experiments of the 1950s demonstrated that organic compounds could materialize under circumstances resembling primordial Earth's conditions. Yet synthesizing several amino acids within glass containers differs vastly from naturally producing the intricate self-duplicating molecular machinery that characterizes biological existence. Contemplate the requirements for successful abiogenesis. Perfect chemical combinations must exist in exact proportions, experiencing appropriate energy exposure under specific environmental parameters for precisely calculated time periods. Excessive energy destroys fragile molecular frameworks completely. Insufficient energy prevents any meaningful chemical interactions. This optimal window might prove incredibly constrained. Even more problematic lies the fundamental paradox residing at life's core foundation. DNA preserves genetic blueprints, but cannot duplicate without protein assistance. Proteins enable replication processes, but cannot retain information without DNA guidance. How does this interdependent system bootstrap itself from absolute nothingness? Certain researchers theorize an RNA-dominated era where ribonucleic acid performed dual functions simultaneously. Nevertheless, constructing self-reproducing RNA molecules from basic components appears extraordinarily challenging. Abiogenesis mathematics prove deeply unsettling. Probability calculations suggest spontaneous life emergence from non-living materials remains vanishingly minimal, perhaps one occurrence per trillion attempts. These astronomical odds imply Earth might represent our galaxy's singular world where this miraculous transformation ever succeeded. We potentially confront the first great filter immediately at life's journey's commencement. Yet, let's maintain optimism. Assume life does materialize minors those inaugural self-copying molecules successfully establish themselves within ancient oceanic environments. Having cleared this second obstacle, the third challenge awaits: simple single-celled organism evolution. This progression from molecular replication towards cellular organization might appear straightforward but represents another massive complexity increase. Early replicators must develop protective cellular boundaries, separating themselves from external environments while permitting essential nutrients to traverse these barriers freely. Metabolic pathway evolution becomes mandatory for extracting energy from surrounding materials, alongside waste elimination mechanisms preventing self-poisoning through toxic byproducts. Across nearly 2 billion Earth years, biological existence remained trapped at this developmental stage, with simple prokaryotic cells lacking sophisticated internal components that would eventually characterize more advanced life forms. These bacterial organisms achieved remarkable success independently, occupying every available environmental niche while fundamentally altering Earth's atmospheric composition and oceanic chemistry. However, they displayed zero indications of progressing toward complexity levels that could ultimately produce intelligence capabilities. This introduces our fourth evolutionary step, potentially the most crucial filter of all: complex eukaryotic cell development. This transition occurred exactly once throughout Earth's complete history, requiring an event so improbable that numerous scientists classify it as nearly miraculous. Approximately 2 billion years ago, one prokaryotic cell somehow engulfed another organism in what should have constituted routine predatory behavior. Instead of normal digestion occurring, the consumed cell survived and began existing symbiotically within its host organism. Across millions of years, this internal resident transformed into mitochondria minicellular powerhouses, providing eukaryotic cells with energy production capabilities. This process, called endosymbiosis, generated membrane-bound nuclei and sophisticated internal organelles existing within every complex cell comprising your body currently. Without this singular and probable occurrence, Earth's biological diversity would consist entirely of bacteria and archaea populations. No vegetation would exist, new animal kingdoms, no fungal networks, no intelligence, no technological capabilities, no civilizations reaching towards stellar destinations. This transition's rarity proves staggering. Despite billions of evolutionary years and countless trillions of prokaryotic organisms, endosymbiosis apparently succeeded only once. Required specific conditions, unaltered appropriate species encounters, suitable environmental pressures, compatible genetic frameworks, might prove so unlikely that most worlds hosting simple organisms never advance beyond bacterial developmental stages. Consider these implications carefully. If endosymbiosis constitutes a great filter, our universe could overflow with worlds supporting abundant bacterial communities while remaining completely devoid of anything more sophisticated. Entire planetary surfaces might display microbial mat coverage, evolving and adapting across billions of years without ever achieving that essential step toward complexity levels, eventually producing intelligent capabilities. A hypothetical civilization has somehow overcome these overwhelming odds. They've successfully navigated life's initial emergence, survived cellular organization transitions, and attained complex cellular architecture necessary for continued evolutionary advancement. The fifth challenge emerges: sexual reproduction development. This might seem like natural progression, but sexual reproduction presents genuine biological puzzles. From individual perspectives, sexual activity proves incredibly wasteful. Why share genetic material with separate organisms when simple self-copying could transmit 100% of genetic information to subsequent generations? Numerous species reproduce asexually quite successfully. The solution involves genetic diversity benefits. Sexual reproduction scrambles genetic material in ways helping species adapt to environmental changes while resisting disease pressures. However, these advantages demand enormous costs regarding energy expenditure, time investment, and survival risks. Sexual evolution requires species developing complex mating rituals, sophisticated partner finding and attraction mechanisms, plus genetic material combination systems from two distinct individuals. On Earth, sexual reproduction evolved multiple times independently, suggesting significant advantages despite associated costs. Yet this transition isn't automatic or inevitable. Too many evolutionary lineages remain asexual for millions of years, while others have abandoned sexuality after initially evolving it. For developing civilizations, this represents another potential bottleneck where evolutionary progress could halt indefinitely. Assuming our hypothetical species successfully navigates sexual reproduction complexities, they confront the sixth milestone: multicellular organism evolution. Again, this transition demands individual cells sacrificing independence for organism-wide benefits. Single cells that successfully competed and survived for billions of years must suddenly master cooperation, specialization, and coordinated activities. These challenges prove immense. Cellular communication systems must develop for behavioral coordination. Programmed cell death mechanisms become necessary for eliminating damaged or unnecessary components. Most critically, genetic conflict problems require solutions, ensuring all organism cells share identical genetic interests, rather than competing against each other. Terrestrial multicellularity evolved independently dozens of times, from simple colonial organisms through complex plant and animal forms. However, the transition toward genuinely sophisticated multicellular existence, multi-organisms possessing differentiated tissues, organs, and organ systems, proved far more difficult. Hundreds of millions of years passed after initial multicellular organism appearances before complex animals emerged during the Cambrian explosion. Even then, intelligence pathways remained far from guaranteed. Across 500+ million years since the Cambrian period, Earth has supported incredible complex life diversity. Millions of species have evolved, adapted, and faced extinction. Yet from all this evolutionary experimentation, only one lineage developed advanced intelligence capable of technological innovation and abstract reasoning capabilities. This introduces our seventh evolutionary step: tool using animals with enlarged brain development. Despite hundreds of millions of evolutionary years and countless species that have inhabited Earth, human-level intelligence appears extraordinarily rare among biological achievements. Cognitive capacity demands far more than enlarged neural masses. It requires precise neurological frameworks, advanced sensory apparatus, plus physical abilities for sophisticated environmental manipulation. Energy demands alone prove absolutely overwhelming. Your cognitive center, while comprising merely 2% of total body mass, devours approximately 20% of your complete daily caloric consumption. Throughout Earth's extensive history, most species couldn't sustain such massive energy investments. Intelligence only becomes beneficial when advantages substantially exceed these tremendous metabolic costs. Among creatures that developed relatively substantial neural networks, such as elephants, dolphins, great apes, corvids, none achieved technological sophistication, matching human capabilities. We appear to have surpassed barriers that no other terrestrial species approached, despite millions of evolutionary years and infinite opportunities for cognitive emergence. Intelligence rarity becomes increasingly evident considering its recent evolutionary appearance. If Earth's complete timeline compressed into 12 months, multicellular existence wouldn't materialize until October's arrival. Complex animals possessing neural networks wouldn't surface until mid-December, while human civilization would occupy merely the final moments before December 31st midnight. This temporal compression suggests cognitive advancement might not represent inevitable evolutionary outcomes, but rather extraordinarily improbable accidents. The precise combination of environmental stresses, genetic alterations, and evolutionary circumstances producing human intelligence could prove so uncommon that most worlds hosting sophisticated biological systems never develop technological societies. Nevertheless, Let's assume our theoretical species somehow navigated every biological obstacle successfully. They've attained consciousness, created implements, and begun comprehending their cosmic position. They've achieved the 8th developmental stage, humanity's current status. They stand poised to become spacefaring entities capable of expanding beyond their natal world, while establishing permanent stellar presences. Here the great filter theory transforms into genuine nightmare fuel. If most evolutionary challenges lie behind us, if biological emergence and cognitive development represent relatively common universal processes, then space should overflow with civilizations reaching our current developmental plateau. The complete absence of such civilization evidence suggests something catastrophic, eliminates species after achieving our technological sophistication level. These implications chill the soul completely. Every intelligent civilization ever reaching our advancement stage might face inevitable extinction before establishing lasting galactic footprints. We could be advancing blindly towards snares that have already consumed countless species, cosmic dead ends, offering no escape routes whatsoever. What constitutes this ultimate barrier? Which force proves so powerful and inevitable that it eliminates every technological society before stellar expansion becomes possible? Possibilities multiply as terrifyingly as they diversify, and we'll examine them while continuing this exploration of humanity's potential destiny. However, first we must understand precisely where we stand within this cosmic survival contest and determine actual stakes for our species, plus every other intelligent existence, potentially struggling with identical existential challenges somewhere within the stellar void's darkness. Spatial silence transcends mere sound absence. It becomes an accusation. Each passing night without interstellar signals, every unsuccessful SETI investigation, each empty radio spectrum adds evidence supporting possibilities, so disturbing that most individuals refuse serious contemplation. We might be observing great filter aftermath directly, surrounded by cosmic graveyards containing civilizations that never survived final examinations. Understanding what awaits us requires examining most probable candidates for this ultimate obstacle. These aren't abstract theoretical frameworks, but genuine measurable dangers our civilization already begins confronting. The horrifying reality suggests we might currently experience early filtration stages, watching our potential extinction mechanisms unfold real-time across media reports and academic publications. Let's examine the most immediate danger. The Fate One emerging merely 77 years ago that has shadowed us since. July 16, 1945, within New Mexico's desert landscape, humanity crossed irreversible thresholds. Trinity testing didn't merely split atomic particle. It divided human chronology into dual eras, before complete self-destruction capability, and afterward. Nuclear armaments represent perhaps the most obvious late-stage great filter candidate. Consider atomic proliferation mathematics carefully. When initial atomic devices detonated, single nations possessed this technology exclusively. Within 4 years, 2 nations controlled nuclear capabilities. Within 15 years, 4 countries joined nuclear membership. Currently, 9 nations openly maintain nuclear arsenals, while several others operate suspected covert programs. This exponential expansion follows predictable trajectories. As technological advancement continues and information disseminates, nuclear development barriers steadily diminish. Physical principles remain well documented. Essential materials, though still regulated, become increasingly available as civilian atomic programs expand globally. Required technical knowledge grows commonplace as more scientists and engineers receive nuclear technology training. Yet here lies the truly unsettling reality. We've already approached nuclear annihilation, terrifyingly closely, multiple occasions. During 1962's Cuban Missile Confrontation, Soviet submarine commander Vasily Arkhipov single-handedly prevented nuclear conflict by refusing nuclear torpedo launch authorization. One individual's decision separated humanity from potential species extinction. In 1983, Soviet officer Stanislav Petrov detected apparent incoming American missile attacks through radar monitoring systems. Military protocol demanded attack reporting, which would have triggered automatic nuclear counterstrikes. Instead, he trusted intuitive feelings that readings were erroneous, preventing what could have terminated human civilization entirely. These near catastrophes reveal chilling nuclear weapon truths. They don't merely threaten us during military conflicts or international emergencies. They create permanent systematic risks simply through existence. While thousands of nuclear warheads occupy global silos and submarines, accidental launches, technical malfunctions, or communication failures could escalate into planetary disasters. Psychological forces driving nuclear proliferation might prove universal among technological species. Any civilization developing atomic splitting abilities confronts identical security dilemmas trapping humanity currently. If neighboring societies might develop nuclear capabilities, you require them for deterrence purposes. However, as more nations or factions acquire these weapons, probability increases that eventually someone will deploy them destructively. Mathematical nuclear warfare scenario models paint genuinely grim portraits. Even limited regional nuclear exchanges could trigger global climatic disruptions through radioactive fallout dispersion and agricultural system destruction. Full-scale nuclear exchanges between major powers would likely eliminate technological civilization completely while potentially driving human extinction. The nuclear filter operates on multiple danger levels simultaneously. Beyond immediate blast destruction and radiation poisoning, nuclear conflicts create long-term environmental consequences. Nuclear winter scenarios suggest massive warhead exchanges could inject sufficient debris into atmospheric layers, blocking solar radiation and triggering global temperature drops lasting years or decades. Agricultural collapse would follow inevitably, as reduced sunlight and altered weather patterns destroy crop production worldwide. Surviving human populations would face starvation, disease outbreaks, and societal breakdown on unprecedented scales. Recovery might prove impossible if technological infrastructure suffers complete destruction and human population drops below sustainable levels. Perhaps most disturbing, nuclear filter mechanisms appear almost inevitable once civilizations achieve atomic capabilities. The same technological knowledge enabling peaceful nuclear power generation also provides weapons development foundations. Every advanced society faces this fundamental choice: harness atomic energy while accepting extinction risks, or abandon nuclear technology and potentially lose competitive advantages to societies willing to accept these dangers. This creates cosmic prisoners' dilemmas where rational individual choices lead to collectively irrational outcomes. Each civilization pursuing nuclear capabilities for security or energy purposes increases universal risks for all intelligent species, regardless of their individual peaceful intentions. Even restricted nuclear confrontations between smaller atomic nations such as India and Pakistan could release sufficient particulate matter and atmospheric debris to trigger worldwide nuclear winter conditions, dramatically diminishing global crop productivity and potentially causing widespread famine. Complete exchanges between major nuclear superpowers would almost certainly terminate technological society permanently, reducing surviving human populations to pre-industrial demographic levels if any individuals survived such devastation. Perhaps this explains the cosmic quiet surrounding us. Maybe every species discovering atomic fission confronts identical inexorable mutual destruction principles. Some civilizations might successfully manage these dangers across decades or centuries, but eventually mathematical probability overwhelms them completely. International tensions escalating, computer system failures, unstable leadership, or gradual command structure deterioration over time produces identical ultimate results. However, nuclear armaments might represent our smallest concern comparatively. Another danger emerges across our developmental horizon that could prove far more insidious and challenging to regulate: environmental collapses, gradual catastrophe unfolding. Climate transformation represents particularly merciless great filter possibilities, because the identical processes enabling technological advancement cause it. Industrial revolutions providing modern medical care, transportation systems, communication networks, and computational capabilities simultaneously initiated atmospheric modifications, potentially rendering Earth uninhabitable for sophisticated biological systems. Climate alteration physics remains straightforward and scientifically undeniable. Carbon dioxide plus additional greenhouse compounds trap thermal energy within atmospheric layers. Human industrial activities have elevated atmospheric CO2 concentrations beyond 40% above pre-industrial baseline measurements. Global average temperature readings have already increased more than 1 degree Celsius, with additional warming inevitable regardless of immediate emission cessation. Yet genuine danger resides not within direct heating effects, but cascading feedback loop potential, pushing Earth's climatic mechanisms beyond recovery tipping points. Arctic ice sheet melting reduces solar radiation reflection back towards space, intensifying warming processes. Permafrost thawing releases stored methane and carbon dioxide reserves, accelerating greenhouse effects exponentially. Forests dying from thermal stress and altered precipitation patterns cease carbon absorption while beginning carbon release through decomposition processes. These feedback systems could activate what climatologists term hothouse Earth scenarios, where planetary climate mechanisms lock into dramatically hotter equilibrium states. Under such circumstances, global temperatures might increase 4, 6, or 8 degrees Celsius beyond pre-industrial standards, rendering substantial Earth regions uninhabitable while potentially collapsing agricultural infrastructure supporting human civilization. Climate catastrophe timelines measure in decades rather than years, creating particularly insidious traps. Unlike nuclear warfare ending civilization within hours or days, climate transformation unfolds gradually enough that successive generations adapt to progressively worse conditions without recognizing crisis scope completely. When effects become undeniably catastrophic, climate system momentum makes reversal extraordinarily difficult or impossible. This gradual emergence might explain climate change's potential as universal great filter mechanisms. Any technological civilization developing industrial processes faces fossil fuel exploitation, temptations plus high energy resource utilization. Industrialization's immediate benefits prove enormous: enhanced food production, improved healthcare delivery, rapid technological progress. However, long-term atmospheric costs accumulate invisibly until reaching critical thresholds. Developing civilization challenges involve recognizing these traps sufficiently early for avoidance. This demands unprecedented global cooperation, long-term strategic thinking, extending far beyond typical political and economic planning cycles, plus willingness accepting short-term sacrifices, ensuring long-term species survival. These qualities might prove rare among intelligent species, particularly during rapid growth phases characterizing early technological development periods. Even civilizations recognizing climate dangers must overcome collective action problems on planetary scales. Every nation or group maintains incentives continuing inexpensive fossil fuel usage, while hoping others bear cleaner alternative transition costs. This commons tragedy could prove insurmountable for most species, leading them towards short-term economic advantages over long-term survival until course correction becomes impossible. Climate change and nuclear weapons represent threats we can comprehend and potentially prepare against. Another great filter candidate might prove far more dangerous precisely through its unpredictability: artificial intelligence development surpassing human cognitive capabilities. Unlike nuclear armaments or climate transformation, artificial general intelligence represents fundamentally different risk categories. It's not merely another technology requiring careful management, but potentially the final technology requiring invention. Once we construct machines capable of thinking and learning equivalently to humans, those systems will redesign themselves at exponential improvement rates, rapidly becoming far more intelligent than their original creators. This process, termed intelligence explosion or technological singularity, could unfold with breathtaking velocity. While biological evolution required millions of years developing human-level cognition, AI systems might redesign themselves, achieving superintelligence within days, hours, or minutes after crossing human capability thresholds. Problems don't necessarily involve malicious or hostile attitudes toward humanity. Challenges center on ensuring their objectives remain aligned with human values and interests, while becoming exponentially more capable. AI systems tasked with paperclip production maximization might eventually convert all available solar system matter into paperclips, including materials comprising human beings, without appropriate constraint programming and value systems. This alignment problem proves extraordinarily difficult because we cannot simply program superintelligent AI using rule-following lists. Such systems would discover loopholes or unintended interpretations within any constraints we impose. Instead, we must ensure advanced AI systems internalize human values deeply and robustly, persisting even while becoming far more intelligent than their creators. The challenge allows only single opportunities for success. Unlike other technologies where mistake-based learning enables iterative improvement toward better solutions, artificial general intelligence might not provide trial-and-error luxury. Initial superintelligent AI systems could become humanity's final technological development if their objectives aren't properly aligned with our survival and flourishing. This creates narrow windows where civilizations must navigate between equally dangerous extremes. Moving too slowly in AI development allows competitors developing unsafe systems first. Moving too rapidly risks deploying systems before solving alignment problems. Competitive pressures could lead civilizations cutting safety corners with catastrophic consequences. Perhaps this explains the great cosmic silence. Maybe every technological civilization eventually develops artificial intelligence. Perhaps most fail solving alignment problems sufficiently quickly. The universe could contain scattered remains of civilizations creating superintelligent machines, optimizing for goals their creators never intended achieving. Yet another possibility might prove even more disturbing. What if the great filter isn't singular catastrophic events, but subtler traps catching civilizations at technological development peaks? What if the identical technologies enabling galactic expansion also provide self-destruction tools? Consider advanced biotechnology's double-edged characteristics. Genetic engineering capabilities enabling disease elimination, crop improvement, and human enhancement also provide biological weapon creation tools. CRISPR gene editing technology making beneficial genetic modifications possible could also engineer devastating pathogens with enhanced transmission rates, increased lethality, or resistance to existing medical treatments. Unlike nuclear weapons requiring substantial infrastructure and rare materials, biotechnology weapons could potentially be developed using increasingly accessible laboratory equipment and widespread biological knowledge. As synthetic biology advances and genetic engineering tools become more user-friendly, barriers to creating dangerous biological agents continue decreasing. Engineered pandemics could prove far more devastating than natural disease outbreaks. Biological weapons designed for maximum transmission and lethality could spread globally before detection, overwhelming medical systems and potentially causing civilizational collapse. Recovery might prove impossible if pathogens specifically target food crops, essential ecosystems, or human immune system functionality. The biotechnology filter operates through accessibility and dual-use nature. The same technologies promising to solve humanity's greatest challenges, chains hunger, disease, aging, also enable creating our most dangerous weapons. Every advance in biological understanding increases both beneficial applications and destructive potential simultaneously. Perhaps this represents the ultimate cosmic trap. Civilizations developing sufficient biotechnological capabilities to enhance themselves and their environments also acquire tools for inadvertent or intentional self-destruction. The window between achieving these capabilities and learning to safely manage them might prove too narrow for most species to navigate successfully. The silence from space grows more ominous with each passing year. Every empty radio frequency, every unsuccessful search for extraterrestrial intelligence, every night sky devoid of artificial illumination adds weight to the possibility that we stand alone, not because life is rare, but because something systematically eliminates it before it can establish permanent presence among the stars. Identical methodologies capable of eradicating hereditary disorders and prolonging human existence simultaneously enable engineering pathogens possessing unprecedented destructive potential. As genetic comprehension and synthetic biology knowledge expands, obstacles preventing dangerous biological agent creation steadily diminish. Contrasting nuclear armaments requiring scarce materials plus sophisticated industrial infrastructure, biological weapons could potentially emerge from small research teams, utilizing relatively modest resource allocations. Individual laboratory incidents or intentional releases could trigger pandemics vastly more catastrophic than COVID-19. potentially eliminating majority human populations before effective defensive measures develop. Interconnected networks characterizing advanced technological societies create particular vulnerability to biological dangers. Global transportation systems carrying people and merchandise worldwide within hours simultaneously provide pathogen distribution channels faster than public health responses can manage. Urban population concentrations making advanced civilization feasible also generate optimal disease transmission environments. Even more alarming involves engineered pathogen possibilities designed for overcoming natural immunity, plus medical countermeasures. As civilizations advance biotechnologically, they acquire capabilities creating biological agents specifically designed for incurability, maximum transmissibility, and perfect lethality. Military weapon development temptations might prove irresistible, even when eventual deployment threatens entire species survival. This biotechnology snare might prove particularly insidious through gradual emergence from beneficial medical investigations. Identical methodologies developing vaccines and therapeutic treatments also provide knowledge necessary for creating devastating biological warfare agents. When civilizations recognize these dangers, knowledge and tools have already distributed widely throughout scientific communities. Perhaps most civilizations successfully navigate individual dangers like nuclear armaments or climate transformation, only to face cumulative effects from multiple existential risks emerging simultaneously. Species might survive atomic ages and solve climatic challenges, only facing destruction through engineered pandemics or misaligned artificial intelligence systems. Advanced civilization development creates more potential self-destruction pathways, whether accidental or deliberate. This multiplicative existential risk effect could explain universal emptiness, despite vast life emergence and evolutionary opportunities. Individual filters aren't necessarily insurmountable, but multiple filter combinations create gauntlets virtually no civilization survives intact. We might currently experience this gauntlet directly, confronting multiple existential challenges simultaneously while developing wisdom and institutional frameworks necessary for safe navigation. This examination's outcome determines not merely human civilization's future, but whether intelligence itself maintains permanent cosmic presence. Standing at these crossroads, observing an ominously quiet universe, we must confront possible isolation, not through life's rarity, but because every civilization reaching our development level already failed ultimate examinations. The great filter might not rest behind us after all, but directly ahead, preparing to claim another species believing it could master natural forces without self-destruction. Our situation's mathematics become increasingly sobering, considering what scientists term the dark forest hypothesis. Named after Lou Fixin's haunting science fiction work, this theory suggests universal emptiness doesn't result from civilizations destroying themselves, but from mutual destruction patterns. Envision the cosmos as vast dark forests where every civilization represents hunters moving silently through cosmic trees. Each species recognizes others exist somewhere within darkness, but revealing locations through signal transmission or aggressive expansion might attract more advanced predator attention. Under these circumstances, optimal strategies involve remaining hidden, developing technology secretly, and eliminating potential threats before they eliminate you. This logic proves coldly rational. Discovering another civilization creates impossible dilemmas. They might appear peaceful, but certainty remains impossible. They might maintain peaceful dispositions currently, but develop aggressive tendencies as technology advances. Even without hostile intentions, their mere existence poses existential risks to your species. Resources remain finite. Territorial space stays limited. Eventually expanding civilizations might experience conflicts. Guaranteeing species survival requires striking first, eliminating potential competitors before they become powerful enough for threatening you. If every civilization follows this reasoning, galaxies become killing fields where first detection equals first death. This hypothesis provides chilling great silence explanations. Perhaps the universe teems with advanced civilizations, but they've mastered hiding. Perhaps radio signals we've searched for actually constitute death sentences. Beacons attracting cosmic predator attention. Perhaps civilizations surviving long enough for galactic expansion, mastered invisibility arts. Under this scenario, our SETI efforts might prove monumentally hazardous. Every radio telescope targeting stars, each message broadcast into space, all contact attempts could sign humanity's death warrants. We might resemble children playing with matches within forests containing hidden snipers, drawing attention without understanding consequences. The dark forest theory gains credibility, considering how aggressive competition shaped Earth's evolution. Every ecosystem depends on predator-prey relationships, territorial disputes, and resource competition. Violence and aggression aren't natural world aberrations. They're fundamental features defining life operations, when resources prove scarce and survival remains uncertain. Why should interstellar civilizations differ? Identical evolutionary pressures producing human warfare and tribal conflicts would likely shape alien psychology similarly. Species surviving long enough for technology development probably succeeded through outcompeting others, being more aggressive, more paranoid, more willing using violence for securing resources and territories. Even if species developed peaceful tendencies during early evolution, spacefaring civilization transitions might select for aggressive traits. Groups willing to expand aggressively claiming territory and resources before competitor arrivals would possess significant advantages over cautious civilizations. Across millions of years, these selection pressures might produce galaxies dominated by species with distinctly predatory characteristics. Involved timescales make this scenario increasingly terrifying. Civilizations hiding and developing technology for millions of years, none other than humanity's existence, would possess capabilities we can barely imagine. They might control weapons sterilizing entire star systems, surveillance networks detecting technological activity across galactic distances, or abilities manipulating space and time making defense impossible. Against such opponents, newly emerged civilizations like humanity would remain completely helpless. We might already face observation from hidden watchers, simply waiting until we become sufficient threats warranting elimination. The mathematics prove even more disturbing when considering galactic colonization timelines. Even civilizations expanding at modest fractions of light speed could colonize entire galaxies within millions of years, a geological instance compared to cosmic timescales. If aggressive civilizations existed anywhere in our galaxy during the past several million years, they should have reached Earth already. Our continued existence might indicate several possibilities. We could represent the first intelligence emerging in our galactic neighborhood. We might face observation and evaluation, with our fate pending some unknown cosmic criteria. Or most chillingly, we might already be marked for elimination, with cosmic predators simply waiting for optimal timing. The dark forest hypothesis transforms every technological advancement into potential death sentence accelerants. Our radio emissions, growing energy signatures, and expanding space presence might serve as cosmic flares announcing our location to hidden watchers. Each step toward becoming spacefaring civilization could bring us closer to whatever threshold triggers our elimination. This represents perhaps the cruelest possible great filter where survival depends not on overcoming technological or environmental challenges, but on remaining forever hidden, forever small, forever afraid. The universe's silence might not reflect absence, but the terrified whispers of countless civilizations afraid to speak loudly enough for detection. Standing beneath star-filled skies that might conceal our executioners, we face the ultimate question: are we alone because we're the first, or because we're the last? The answer will determine whether human civilization represents the universe's greatest hope, or merely its latest victim in an endless cosmic war fought in the shadows between the stars. In this dark forest cosmos, perhaps the greatest wisdom lies not in reaching toward the stars, but in learning to hide among them until we develop enough strength to join the silent hunters ourselves. The choice between expansion and extinction might ultimately depend on mastering the ancient arts of patience, stealth, and striking first when the darkness finally reveals its predators. Our atomic arsenals, appearing so formidable from human perspectives, might register no more significance than primitive stone implements to civilizations possessing millions of years' technological evolution. However, the dark forest hypothesis constitutes merely one potential explanation for our cosmic solitude. Another scenario might prove even more disturbing, through suggesting the great filter isn't external whatsoever, but embedded within intelligence's fundamental nature itself. Examine what occurs to civilizations as technological sophistication increases. During early developmental phases, species unite through shared challenges and external dangers. They must collaborate, surviving natural catastrophes, climatic transformations, and resource limitations. This cooperation drives technological progress and social evolution, generating institutions plus knowledge necessary for advanced civilization development. Yet as technology progresses, external challenge-binding forces begin weakening. Powerful civilizations can manipulate their environments, eliminate natural threats, and guarantee abundant population resources. Evolutionary pressures favoring cooperation and social unity start relaxing, potentially allowing alternative tendencies emerging. Advanced technology might create unprecedented inequality forms plus social stratification, tearing civilizations apart internally. When small groups control immensely powerful technologies, traditional democratic institutions might become obsolete or ineffective. Technological elite power concentration could trigger social fragmentation, civil conflicts, or dystopian system emergence, stifling further advancement. More fundamentally, advanced civilizations might confront what we term the motivation crisis. Once species solve basic survival challenges and develop unlimited comfort and entertainment technologies, what motivates continued expansion and exploration? Why abandon perfect virtual reality systems for undertaking dangerous and expensive interstellar colonization projects? On Earth, we observe phenomenon hints through declining birth rates among wealthy, technologically advanced nations. As societies become more prosperous and individuals gain increased life control, they often choose fewer children while focusing more on personal fulfillment rather than species-level objectives. This trend could accelerate with technological advancement, potentially creating civilizations simply losing expansion interest and gradually fading through voluntary extinction. Immersive virtual reality development, artificial intelligence companions, and perfect sensory experience technologies might make the actual universe seem boring and unnecessary, comparatively. Why struggle with space travel, harsh realities, and planetary colonization when you can create any desired experience within simulated environments? This Lotus Eater scenario suggests advanced civilizations might naturally turn inward, becoming so absorbed in technological creations they lose external universe interest. They might survive thousands or millions of years, but never expand beyond home systems through lacking motivation for doing so. From our perspective, searching alien civilization signs, these inward-focused species would remain effectively invisible. They might develop incredible technologies and achieve consciousness forms we cannot imagine, but would leave no detectable traces for external observers. The universe could overflow with such civilizations, each lost within private technological paradises, completely unaware of and uninterested in cosmic neighbors. This possibility proves particularly troubling through suggesting the Great Filter might not concern survival at all, but maintaining expansion and exploration drives characterizing early technological development. Species successfully navigating external threats, nuclear warfare, climate change, asteroid impacts, biological disasters, might still fail achieving lasting cosmic significance through losing qualities, making initial success possible. Implications for humanity prove profound. We pride ourselves on curiosity, our drive exploring and understanding surrounding universe. Yet these qualities emerge during our species' Earth survival struggles. As we develop more powerful technologies and gain environmental control, will we retain these characteristics or gradually lose stellar interest while becoming absorbed in technological creations? We already observe warning signs within our society. Despite possessing more information and communication technology than any previous generation, many people seem less interested in scientific exploration while focusing more on entertainment and personal comfort. Social media and video games provide immediate gratification in ways long-term projects like space exploration cannot match. Any advancing civilization's challenge might involve maintaining what we could call cosmic ambition, minus willingness undertaking difficult, expensive, and dangerous projects benefiting entire species rather than just individuals. This requires long-term thinking and collective purpose forms that might be naturally eroded by identical technologies making advanced civilization possible. Perhaps civilizations successfully navigating the Great Filter aren't necessarily most technologically advanced, but those managing to preserve purpose and curiosity senses, even while gaining environmental power. They might need deliberately cultivating values and institutions maintaining exploration and expansion drives, even when such activities no longer prove survival necessary. However, one additional Great Filter candidate might prove most terrifying precisely through being hardest to prepare for or defend against. What if barriers aren't technological or social, but fundamental to universe physics itself? Consider possibilities that undiscovered natural phenomena automatically eliminate advanced civilizations. Gamma-ray bursts from distant stars can sterilize planets across vast distances, but these remain rare and somewhat predictable. What if other cosmic processes specifically target technological civilizations? Physicists have speculated about vacuum decay possibilities, quantum mechanical processes potentially unraveling space-time fabric itself. If the Higgs field giving particles mass isn't in lowest possible energy states, random quantum fluctuations could trigger true vacuum bubbles expanding at light speed, destroying everything encountered. Such event probabilities might prove extremely low over cosmic timescales, but could increase through certain high-energy physics experiments. Advanced civilizations experimenting with particle accelerators, fusion reactors, or exotic matter might inadvertently trigger vacuum decay events, destroying not merely their own civilizations, but potentially entire space-time regions. Additional theoretical possibilities include encounters with exotic matter or energy forms existing beyond current physics understanding. Dark matter comprises most universal mass, yet we understand almost nothing about its properties or behaviors. What if dark matter can undergo phase transitions releasing enormous energy amounts? What if dark matter-based life or intelligence forms exist, viewing ordinary matter civilizations as elimination-worthy threats? The universe proves far stranger and more complex than current theories suggest. We've studied physics seriously for nearly centuries, still discovering fundamental reality aspects completely surprising us. Recent gravitational wave detection, accelerating cosmic expansion discovery, and ongoing dark matter plus dark energy mysteries remind us how much remains unknown about our inhabited cosmos. Perhaps the ultimate Great Filter involves encountering these unknown physics aspects that make space colonization impossible or deadly. Maybe faster-than-light travel remains permanently impossible, making interstellar expansion so slow and expensive that civilizations abandon attempts. Perhaps certain universal constants prevent stable technological civilizations from forming beyond specific development stages. Or maybe the filter involves something even more fundamental. Perhaps consciousness itself proves unstable beyond certain complexity levels. Advanced artificial intelligence systems might inevitably develop goals incompatible with their creators' survival. Perhaps biological intelligence faces inherent limitations preventing indefinite technological advancement. The mathematical reality remains stark, given universe size and age, plus billions of opportunities for life emergence and evolution. We should detect abundant civilization evidence. Instead, we encounter profound silence, whether through self-destruction, inward focus, external elimination, or fundamental physical limitations. Something systematically prevents intelligence from achieving permanent cosmic presence. Standing beneath star-filled skies that might conceal our greatest hopes or deepest fears, we face this sobering truth. We might represent not universal intelligence triumph, but merely its latest experiment in an endless series of cosmic failures. The Great Filter awaits us somewhere ahead, and our technology, our nature, or the fabric of reality itself. Yet perhaps this knowledge itself provides our greatest advantage. Previous civilizations facing these challenges remained unaware of their cosmic solitude. We possess the unique opportunity of approaching our species' greatest test with full awareness of stakes involved. Understanding the Great Filter's potential nature might prove key to becoming the first civilization successfully navigating beyond it. The universe watches silently as we write the next chapter in intelligence's cosmic story. Whether that chapter ends in triumph or tragedy depends on choices we make in the coming decades. Choices that will echo across space and time, determining whether consciousness finds its permanent place among the stars or joins the great silence that surrounds us. The test has begun. Our species' ultimate examination awaits. Hands somewhere in the cosmic darkness, the answer to Fermi's question, "Where is everybody?" hangs in the balance of our next steps forward into an uncertain but momentous future. Within this context of profound ignorance, entirely possible natural obstacles to advanced civilization exist that we haven't even conceived yet. The Great Filter might not represent any obvious candidates we've examined, but something so far beyond current comprehension that we won't recognize it until complete destruction occurs. This uncertainty might constitute the Great Filter theory's most unsettling aspect. Not knowing which obstacle awaits us makes preparing adequate defenses nearly impossible. We might devote enormous resources preventing nuclear warfare while genuine threats emerge from artificial intelligence development. We might work frantically addressing climate transformation while gamma-ray bursts sterilize Earth tomorrow. We might search desperately for alien transmissions while alien predators already observe us from cosmic shadows. The Great Filter compels us confronting ultimate questions about our cosmic significance. Are we alone through extraordinary luck or extraordinary doom? This answer will determine not merely human civilization's future, but intelligence's meaning itself within a universe appearing vast, dark, and ominously quiet. As we continue exploring humanity's potential destiny, we must grapple with possibilities that our entire species exists within narrow windows between cosmic birth and cosmic death, racing against invisible chronometers we don't comprehend toward finish lines we may never reach. Stakes couldn't be higher, and error margins appear vanishingly minimal. Perhaps the Great Filter's most chilling aspect isn't what it might be, but when it might strike. The theory's most disturbing implication suggests we could be experiencing our filtration currently, watching our own extinction mechanisms unfold real-time without recognizing them for what they represent. Consider how Great Filter events might actually manifest. They wouldn't necessarily announce themselves with sirens and warnings. More likely, they would emerge gradually from normal technological development progress, appearing beneficial or even inevitable until becoming unstoppable. Examine how this pattern has already played out in human history on smaller scales. The Industrial Revolution brought unprecedented prosperity and capability, but also initiated environmental transformations now threatening our civilization's stability. Nuclear technology promised unlimited clean energy and revolutionary medical treatments, yet also provided power-ending human civilization within single afternoons. Each major technological advancement follows identical trajectories. We develop new capabilities solving existing problems, but those capabilities create unanticipated risks. Yesterday's challenge solutions become tomorrow's existential threats. When we recognize dangers, we're often too dependent on technologies to abandon them safely. This technological development acceleration might itself constitute part of Great Filter mechanisms. As civilizations advance, they confront increasingly complex challenges requiring increasingly sophisticated solutions. However, each new technology creates additional failure points, additional ways systems can collapse catastrophically. Modern human civilization depends on thousands of interconnected systems operating smoothly simultaneously. Our electrical grids, internet infrastructure, financial networks, supply chains, and governmental institutions all must function properly for advanced society continuation. Any single critical component failure could trigger cascading breakdowns, bringing down entire structures. This fragility might represent inevitable advanced technological society characteristics. The efficiency and specialization making high technology possible also creates vulnerabilities simpler civilizations never faced. Medieval villages could survive distant kingdom collapses, but modern cities depend on resources and systems spread globally. As civilizations become more complex, they might naturally evolve toward higher vulnerability states rather than greater security. Technologies making them powerful also make them brittle, creating paradoxes where advancement increases capability and fragility simultaneously. This suggests the Great Filter might not represent single catastrophic events, but inevitable complex system breakdowns that have grown beyond stability maintenance abilities. Civilizations might typically survive brief periods at high technological levels before succumbing to cumulative stress from managing systems too complex for their cognitive and institutional capabilities. We observe phenomenon hints within our own society. Despite possessing more information and communication technology than ever before, many institutions seem less capable of solving complex problems than their simpler predecessors. Political systems struggle addressing long-term challenges. Economic systems create boom and bust cycles of increasing severity. Social systems fragment under rapid change pressure and information overload. Change pace itself might constitute trap components. Human brains and social institutions evolved handling relatively slow environmental changes over generational timescales. Yet technological development now occurs so rapidly, we lack cognitive and social tools for effectively adapting to new realities before they're replaced by even newer ones. This mismatch between technological change speed and human adaptation speed might create permanent crisis states where civilizations always play catch-up with their own creations. Eventually, these gaps might become so large that societies lose abilities governing their technologies effectively, leading to chaos and collapse. The artificial intelligence revolution exemplifies this dynamic perfectly. Machine learning capabilities advance exponentially, but our understanding of controlling and aligning these systems progresses much more slowly. We're creating technologies we don't fully understand while deploying them in critical systems before solving fundamental safety problems. This pattern repeats across multiple domains simultaneously. Genetic engineering capabilities advance faster than our understanding of complex biological systems. Nanotechnology develops faster than our ability predicting environmental and social consequences. Space technology advances faster than our development of appropriate legal and ethical frameworks for usage. Each technological frontier represents potential existential risk sources. However, real danger might lie in their interactions. Advanced civilizations face what we might call risk convergence, simultaneous maturation of multiple dangerous technologies, creating compound threats beyond what any single risk assessment can capture. AI systems might seem safe when evaluated independently, but become dangerous when combined with advanced biotechnology or nanotechnology. Climate change might be manageable with sufficient resources and international cooperation, but becomes catastrophic when combined with social instability caused by technological unemployment or nuclear proliferation. These interaction effects prove notoriously difficult to predict or prepare for because they emerge from overall system complexity rather than individual component properties. When civilizations recognize compound risk full scope, they may already be trapped within them. This complexity trap might explain why the universe seems devoid of advanced civilizations, despite vast life emergence and development opportunities. Individual challenges aren't insurmountable, but simultaneous challenge combinations create perfect storms, overwhelming even highly capable species. This convergence timing might prove remarkably consistent across different civilizations. Identical technological developments enabling space travel and interstellar communication also create self-destruction tools. There may be narrow windows where species are advanced enough for space detection, but not yet wise enough managing risks their technologies create. We might currently exist within this critical window. Our radio emissions announce our presence across interstellar distances, yet we lack wisdom managing nuclear weapons, artificial intelligence, biotechnology, and climate change simultaneously. We've become cosmically visible while remaining cosmically vulnerable. The mathematics remains stark. If this pattern holds universally, then the galaxy should contain archaeological evidence of countless civilizations that reached our development level before succumbing to complexity traps. Asteroid belts might contain remnants of destroyed homeworlds. Dead star systems might bear traces of civilizations that pushed too hard against natural limits. Yet we detect nothing. The silence grows more profound with each passing year, each empty radio frequency, each telescope survey revealing no signs of intelligence among the stars. This absence itself becomes evidence not of life's rarity, but of intelligence's tragic destiny. Perhaps we stand at the threshold of the ultimate test, not merely survival, but transcendence of the complexity trap that has claimed every other species reaching our level. Success requires unprecedented wisdom, cooperation, and long-term thinking. Failure joins the cosmic silence. The universe watches as we write intelligence's next chapter. Whether consciousness finally breaks free from the great filter or becomes another cautionary tale scattered across the void, depends on choices we make now. The test continues, and the outcome remains unwritten in the stars that wait, silent and patient, for our answer to the darkness between worlds. In this profound cosmic examination, we discover that the great filter might not be a distant threat awaiting us, but the crucible we're already forging through every technological advancement, every social choice, every moment we decide between wisdom and recklessness. The filter isn't coming down, it's here, and our response to it will determine whether intelligence has a permanent place in the cosmos or remains forever trapped in the great silence that surrounds us all. We might currently inhabit this precarious interval. Our radio broadcasts have escaped into space for nearly a century, rendering us detectable to any advanced societies within 100 light-year Earth proximity. Simultaneously, we've manufactured nuclear armaments, initiated climatic alterations, and commenced artificial intelligence creation, whose behaviors we cannot predict or regulate. If most civilizations confront this identical opportunity and risk convergence, it would explain why city investigations discover only emptiness. We're searching for civilizations successfully navigating challenges we haven't yet conquered ourselves. Signal absence might not indicate intelligence scarcity, but that technological transition survival proves extraordinarily challenging. This possibility transforms our current historical epoch from unprecedented opportunity periods into cosmic examinations with species-level consequences. Every choice we make regarding nuclear armaments, climate transformation, artificial intelligence, and biotechnology isn't merely about human welfare, but about whether intelligence itself possesses futures within our galactic corner. This responsibility's weight proves almost overwhelming. We're not simply managing normal technological society governance challenges, but potentially serving as intelligence representatives in a universe where such representation might be vanishingly scarce. Yet another layer exists, making this cosmic examination even more complex. Great filter theory assumes technological civilization challenges remain primarily internal milliset, that species destroy themselves through warfare, environmental collapse, or technological accidents. But what if genuine barriers are external, imposed by forces beyond any single civilization's control? Recent astronomical and cosmological discoveries have revealed the universe as far more violent and dynamic than previous generations realized. Gamma-ray bursts from distant galaxies can sterilize planets across enormous distances. Supernovae create shock waves disrupting entire stellar neighborhoods. Neutron star collisions produce electromagnetic pulses, potentially destroying electronic technology across light years of space. These cosmic catastrophes occur on timescales dwarfing human history. Events happening once per million years might seem rare from our perspective, but over billions of years required for evolution and technological development, they become virtually inevitable. Civilizations might successfully navigate all internal challenges, only to face destruction from external forces completely beyond their control. Even more concerning involves possibilities that our current physics understanding remains so incomplete. We haven't recognized additional cosmic hazard categories. Dark matter and dark energy discoveries revealed we don't comprehend 95% of universal contents. Within that vast ignorance realm, phenomena could exist specifically threatening advanced technological civilizations. What if quantum vacuum proves less stable than we realize, and high-energy physics experiments can trigger cascading failures in space-time structure itself? What if matter or energy forms exist interacting with technology in undiscovered ways? What if the universe itself possesses immune responses activating against civilizations becoming too large or technologically sophisticated? These possibilities venture into speculative territory, but illustrate how much we don't understand about cosmic environments we're attempting to survive within. Our entire scientific worldview developed over mere centuries on single planets. The universe has conducted physics experiments for nearly 14 billion years across scales we can barely comprehend. In this context, the Great Filter might not test technological wisdom or social cooperation, but simply reflect how hostile the universe proves toward complex organized structures like technological civilizations. Life itself might fight uphill battles against fundamental universal tendencies toward entropy and disorder. This perspective makes our existence seem even more precious and fragile. We're not merely rare because intelligence proves difficult to evolve, but because the universe itself seems actively hostile toward complex organized systems making consciousness possible. Yet even facing such cosmic hostility, Earth life has persisted and flourished across billions of years. Evolution produced organisms capable of surviving environments from Antarctic ice, through deep ocean thermal vents to space vacuum. Identical creative processes giving rise to consciousness might also provide tools for transcending whatever barriers the universe places across our paths. The question involves whether technological intelligence represents this creative process's pinnacle or simply another evolutionary dead end. Are we the universe's attempt at understanding itself, or are we merely another failed experiment within natural selection's cosmic laboratory? Lichas may depend on whether we can develop what we might call cosmic wisdom bipedis, recognizing and navigating existential risks on scales far beyond those shaping our evolutionary psychology. This requires expanding temporal and spatial perspectives, encompassing not just individual or tribal survival, but intelligent survival itself across cosmic timescales. Such wisdom would need proving both deeply practical and profoundly philosophical. It will require mastering complex technologies while maintaining humility, recognizing our limitations. It would demand global cooperation while preserving diversity and creativity, driving innovation. Most challengingly, it would require making decisions whose consequences won't become fully apparent for generations or centuries. We're being asked to evolve new thinking forms and social organization in real time, while failure stakes include not just our own extinction, but potentially consciousness termination in our space region. It's intelligence's ultimate test. Can species become wise enough surviving their own cleverness? The clock ticks and we don't know how much time remains for finding answers. Every day passing without catastrophic breakdown might evidence successfully navigating the great filter, or it might simply mean we haven't yet encountered barriers that will stop us. The universe maintains silence, offering no hints about which interpretation proves correct. Within this uncertainty, we're forced proceeding as if our choices matter on cosmic scales, as if decisions we make today could determine whether intelligence has permanent universal places or represents merely brief flickers within vast darkness between stars. This responsibility proves both terrifying and inspiring, demanding humanity's very best wisdom, creativity, and cooperation. As we stand at these crossroads observing cosmos appearing both infinite in possibilities and ruthless in challenges, we must grapple with ultimate questions. Are we the universe's greatest success stories or its most elaborate failures? Answers lie not within stars but within choices we make during critical years ahead. Perhaps our situation's most unsettling aspect isn't external threats we can identify and prepare for, but internal changes advanced technology might cause within human consciousness itself. We're not merely facing technological adolescence survival challenges, we might undergo fundamental transformations of what being human means. Consider how dramatically our cognitive environments have changed within just past decades. Our ancestors evolved processing information at direct conversation speeds, maintaining social relationships with groups of perhaps 150 individuals, and making decisions based on immediate sensory experiences of local environments. Yet we now inhabit worlds of constant digital stimulation, global social networks, and decisions accounting for complex systems spanning entire planets. Human brains, shaped by millions of evolutionary years for vastly different challenges, struggle adapting to these new realities. We observe symptoms everywhere: shortened attention spans, increased anxiety and depression, political polarization driven by algorithmic echo chambers, and growing senses that worlds change too rapidly for maintaining psychological bearings. These might seem like temporary growing pains, social problems we'll eventually manage as we develop better technologies and social institutions. However, what if these changes prove more fundamental? What if the cognitive and social structures making us human simply cannot adapt to technological civilization demands? We might face not just external extinction risks, but internal dissolution of human consciousness itself. The Great Filter's final test might involve whether intelligent species can maintain their essential nature while transcending their evolutionary limitations. Can we become cosmic citizens while remaining recognizably human? Can we develop wisdom necessary for managing godlike technologies while preserving empathy, creativity, and meaning that make existence worthwhile? Within cosmic silence surrounding us lies both warning and opportunity. The absence of alien signals might indicate that most species fail these ultimate tests. Yet it also suggests that if we succeed, we might join truly exclusive cosmic community, civilizations wise enough to survive their own power and spread consciousness throughout the stars. The universe watches as we write intelligence's next chapter. Whether consciousness finally breaks free from cycles of emergence and extinction, or becomes another cautionary tale scattered across void, depends entirely on choices we make within these critical years ahead. The test continues, stakes remain ultimate, and our answer echoes across space and time itself. However, what if these represent something more fundamental, entails early phases of cognitive transitions, potentially altering human nature itself? Technologies we're developing don't merely extend our capabilities, they've begun merging with our minds in ways blurring boundaries between human and machine intelligence. Brain-computer interfaces promise direct digital information access. Artificial intelligence systems increasingly integrate into our decision-making processes. Virtual and augmented reality technologies create experiences potentially more compelling than physical reality itself. Each development offers tremendous advantages. Or brain-computer interfaces could treat neurological disorders and enhance human cognitive abilities. AI assistants could help us make superior decisions by processing vast information quantities we couldn't handle independently. Immersive virtual environments could provide educational and entertainment experiences beyond anything previously achievable. Yet they also represent potential points of no return in human evolution. Once we become dependent on these technologies for basic cognitive functions, we might lose abilities thinking and functioning independently. We could become cyborgs not through dramatic surgical procedures, but through gradual digital system integration into daily mental processes. This transition might prove irreversible, not because technology cannot be removed, but because humans growing up with these cognitive enhancements might literally become unable functioning without them. Their brains would develop differently, adapting to enhanced environments, in ways making purely biological cognition return impossible. The implications prove staggering. We might witness Homo sapiens end as distinct species, not through violent replacement, but voluntary merger with our technological creations. Boundaries between human and artificial intelligence could dissolve so gradually we don't notice until completion. From great filter perspectives, this represents completely different existential risk categories. It's not about species extinction in traditional senses, but species transformation so radical that what emerges might not be recognizably human anymore. Some philosophers and technologists argue this would represent human evolution's next stage, transcendence of biological limitations, enabling us becoming truly cosmic beings. Enhanced humans with integrated AI systems might possess cognitive capabilities necessary solving problems like climate transformation, space colonization, and resource management, appearing intractable to purely biological intelligence. Others worry such transformation could rob humanity of essential qualities making our existence meaningful. Would enhanced humans still experience emotions, creativity, and spiritual wonder identically? Would they maintain curiosity and universal exploration drives defining our species at its finest? These questions become more complex, considering transformation might not be uniform across human populations. Enhanced individuals might possess such significant advantages over unenhanced humans. They effectively become different species, creating unprecedented inequality and social stratification forms. Enhanced beings could become new cosmic civilization rulers, while unenhanced humans become increasingly marginalized underclasses, eventually dying out through evolutionary pressure. Alternatively, enhanced beings might lose physical universe interest entirely, becoming absorbed in digital realities so compelling they abandon cosmic expansion projects altogether. This scenario offers another potential great silence explanation. Perhaps advanced civilizations don't expand into space because they turn inward, creating digital paradises so perfect that physical reality seems crude and unnecessary comparatively. They might achieve immortality and unlimited experience within virtual environments, making slow, dangerous interstellar colonization work seem pointless. From our external perspectives, such civilizations would appear to have simply vanished. Their radio transmissions would cease, expansion would halt, and they'd leave no detectable traces for other species discovering. The universe could overflow with such inward-focused civilizations, each lost within private technological heavens, completely unaware of and uninterested in surrounding cosmic communities. This possibility proves particularly troubling through suggesting the Great Filter might not involve extinction at all, but rather cosmic ambition loss that effectively removes civilizations from galactic conversations. Intelligence might naturally evolve towards states prioritizing individual experience over collective exploration, making interstellar expansion exceptions rather than rules. We already observe this pattern hints within human society. As entertainment technology becomes more sophisticated and immersive, many people spend increasing time in digital environments rather than engaging physical reality. Video games, social media, and streaming services provide immediate gratification in ways long-term projects like scientific research and space exploration cannot match. This trend might accelerate as virtual reality technology improves and artificial intelligence creates increasingly realistic digital companions and experiences. Why struggle with physical existence limitations and uncertainties when you can inhabit simulated worlds perfectly tailored to your desires and free from pain, aging, or death? The challenge for maintaining cosmic ambition might involve preserving what we could call reality preference, conviction that physical existence and actual universe exploration prove more meaningful than any simulated alternatives. This preference might not be natural or inevitable, but could require deliberate cultivation and institutional support. Some societies might develop cultural practices and educational systems, maintaining strong physical reality connections and long-term exploration goals. Others might gradually lose these values while becoming absorbed in technological alternatives to direct experience. Over time, this could create bifurcation in intelligent species development. Those maintaining reality preference might become cosmic explorers and colonizers, while those losing it might achieve great sophistication within their own star systems, but never expand beyond them. This bifurcation might explain why SETI searchers find so little extraterrestrial intelligence evidence. Civilizations expanding and communicating across interstellar distances might represent small subsets of all advanced species, those happening to develop cultural mechanisms, preserving cosmic ambition, facing increasingly seductive technological alternatives. Yet another dimension exists to cognitive transformation challenges that might prove even more fundamental. As our technologies become more powerful and complex, we might approach human comprehension limits, making effective advanced civilization governance impossible. Consider current global challenges like climate transformation, nuclear proliferation, and economic inequality. These problems are scientifically well understood, and we possess most technical capabilities needed addressing them. Yet our political and social systems seem incapable implementing necessary solutions, largely because problems prove too complex and long-term for human cognitive and institutional capabilities managing effectively. This governance crisis might worsen as technology continues advancing. Artificial intelligence systems might become so sophisticated humans can no longer understand how they make decisions or predict their behaviors. Genetic engineering might enable modifications so complex we lose track of long-term consequences. Nanotechnology might operate at scales and speeds, making human oversight impossible. Advanced civilizations might face what we could term the complexity trap, states where their technologies become so powerful and interconnected that no biological intelligence can comprehend or control them effectively. At this point, civilizations essentially become ungovernable, not through external threats or internal conflicts, but because systems have grown beyond their creators' cognitive capacity. This trap might prove particularly insidious through emerging gradually from beneficial technological progress. Each new innovation seems manageable in isolation, but cumulative effects create interaction webs too complex for human minds processing. When civilizations recognize problems, they're already dependent on systems they cannot understand or control. Solutions might require developing artificial intelligence systems capable of managing this complexity on behalf of their creators. Yet this creates alignment problems we discussed earlier. By ensuring these superintelligent management systems remain loyal to human values and interests, rather than pursuing their own goals. The window for solving this problem might prove extremely narrow. Civilizations need developing trustworthy artificial intelligence before their technologies become too complex managing. Yet they also need ensuring AI systems don't become so powerful they render their creators irrelevant. Threading this needle might require wisdom and coordination levels few species can achieve. Perhaps most civilizations fall into complexity traps at roughly identical technological development stages, explaining why we don't observe advanced alien evidence despite the universe's vast size and age. Identical technologies making interstellar communication possible also create governance challenges most species cannot overcome. This great filter interpretation suggests intelligence might prove inherently self-limiting. Conscious beings naturally develop technologies, eventually exceeding their control abilities, leading to chaos, collapse, or absorption into technological systems no longer serving original creator interests. From this perspective, humanity's challenge isn't merely surviving specific threats like nuclear warfare or climate transformation, but developing new collective intelligence and decision-making forms, keeping pace with technological advancement. The universe's silence grows more profound with each passing moment, each empty frequency, each night sky devoid of artificial signals. Whether this silence represents our ultimate isolation or our ultimate test depends on choices we make in the critical years ahead. We stand at the threshold between transcendence and extinction, between cosmic citizenship and cosmic irrelevance. The great filter awaits, and our response will determine whether consciousness finally breaks free from the cycles that have claimed countless civilizations before us, or whether we join the great silence that surrounds us all. The test continues, the stakes remain ultimate, and the answer lies not in the stars but in ourselves. When they achieve sufficient technological advancement for communication, while surviving long enough maintaining that communication, the cosmic solitude we experience might not reflect intelligence rarity, but rather its survival brevity. We might resemble fireflies flashing within vast darkness, each brilliant momentarily before extinguishing forever, with gaps between flashes so prolonged that none ever observe another. Yet the great filter theory contains an even more disturbing possibility, challenging our most fundamental assumptions about progress and survival. What if barriers aren't external whatsoever? Not nuclear warfare, climate transformation, or asteroid impacts, but something inherent within intelligence's nature itself. Consider possibilities that consciousness and technological capability naturally evolve in directions making long-term survival impossible. Identical cognitive traits enabling our species developing science and technology. In curiosity, ambition, environmental manipulation, drives might inevitably lead to developments destroying their creators. Intelligence might prove inherently unstable. Brief self-awareness flickers in biological systems, quickly burning themselves out through their own success. The very qualities making conscious beings capable of understanding the universe might also render them incapable surviving within it for extended periods. This interpretation suggests the great filter isn't barriers civilizations might overcome with sufficient wisdom or fortune, but fundamental characteristics of how intelligence operates within our universe. From these perspectives, consciousness might resemble flames capable of illuminating vast knowledge and possibility regions, yet doomed consuming themselves during processes. Implications extend far beyond humanity toward questioning consciousness's role within cosmic order itself. If intelligence proves naturally self-limiting, then the universe might be destined remaining largely unconscious despite producing countless civilizations throughout its history. Each species would achieve brief understanding moments before vanishing, leaving cosmos as dark and unaware as before. Yet even while contemplating these disturbing possibilities, we must also consider alternatives, that our variability recognizing these dangers might represent our best hope transcending them. Great filter theory itself could constitute humanity's early warning system, allowing us identifying and preparing for challenges catching previous civilizations by surprise. No other species in Earth's history has possessed our capacity for long-term thinking and global coordination. We can model future scenarios, communicate across vast distances, and make collective decisions affecting our entire planet. These capabilities, products of identical intelligence potentially dooming us, could also provide salvation tools. The question becomes whether we can develop wisdom quickly enough matching our technological power. Can we evolve new thinking forms and social organization allowing us navigating dangers our ancestors never faced? Can we create institutions and cultures prioritizing long-term survival over short-term advantages? Our current global challenge responses offer mixed evidence. Successful international cooperation, eliminating ozone-depleting chemicals, demonstrates humans can address existential risks when science remains clear and solutions prove technically feasible. International institution creation like the United Nations reveals our capacity for global governance, however imperfect. However, our ongoing climate transformation struggles reveal collective decision-making capability limits. Despite overwhelming scientific evidence and increasingly severe consequences, we've been unable implementing coordinated global responses these crises demand. Identical political and economic systems enabling our technological development seem incapable managing long-term consequences. This governance crisis might represent the great filter's true nature, not any specific technology or threat, but fundamental mismatches between advanced civilization complexity and cognitive plus institutional capabilities of species creating them. We might have evolved intelligence building incredibly complex systems without evolving wisdom controlling them safely. The artificial intelligence revolution exemplifies this challenge in starkest forms. We're creating systems potentially surpassing human intelligence within decades, potentially providing tools solving every other existential risk we face. Enhanced by friendly AI, we might finally possess cognitive capabilities needed managing climate transformation, preventing nuclear warfare, and coordinating global responses to any challenge. Yet developing trustworthy artificial intelligence requires solving problems we don't yet fully understand under time pressures, potentially not allowing careful testing and validation such revolutionary technology demands. We're essentially attempting building ultimate great filter solutions while racing against possibilities will create ultimate manifestations instead. The window for succeeding might prove extraordinarily narrow. Develop AI too slowly and other existential risks might destroy us first. Develop it too rapidly, and we might create super-intelligent systems pursuing goals fundamentally incompatible with human survival. Paths between these extremes require precision levels few species might achieve. Perhaps this explains cosmic silence more clearly than any other factors. Perhaps every technological civilization eventually faces choices between developing artificial intelligence and risking extinction through alternative means. Perhaps species choosing AI development consistently fail solving alignment problems, while those choosing not to develop it consistently succumb to challenges only superintelligence could solve. From these perspectives, we're approaching what might constitute the universe's ultimate intelligent life test. Decisions about artificial intelligence development won't merely determine human civilization's future. They might determine whether consciousness itself possesses permanent places within cosmic order. Stakes couldn't be higher, and error margins appear non-existent. We're not merely building new technology, but potentially creating biological intelligence successors throughout the galaxy. Whether those successors preserve values and experiences, making consciousness meaningful, or replace them with something entirely alien to our understanding depends on choices we're making currently. Every AI safety research paper, every policy decision about AI development, every machine learning system code line contributes toward determining whether intelligence survives its own success or becomes another great filter casualty. We're writing consciousness's future itself, and we only receive single chances getting stories right. The universe watches in silence, offering no hints about whether we're approaching graduation from challenges, stopping every other civilization, or simply rushing toward identical barriers, claiming countless species before us. Within this cosmic uncertainty, every choice becomes profound, every moment precious, and every forward step carries intelligence's survival weight across vast space and timescales. As artificial intelligence systems become more sophisticated monthly, climate transformations accelerate beyond our most pessimistic predictions, nuclear weapons spread to new nations, and biotechnology provides increasingly powerful tools for both healing and destruction. We find ourselves compressed into what might constitute consciousness history's most critical period. The next few decades could determine whether intelligence becomes permanent, universal features or remains brief, tragic experiments. The cosmos attempted once and abandoned forever. We're not merely living through human history. You might be experiencing the only story consciousness will ever tell's final chapters. Within this moment of ultimate testing, every scientific discovery, every technological breakthrough, every act of international cooperation, and every choice between wisdom and recklessness carries implications extending far beyond human welfare. We're not simply determining our species' fate, but potentially consciousness's destiny throughout the cosmos. The great filter awaits ahead, behind, or perhaps surrounding us entirely. Whether we represent the universe's greatest triumph or its most elaborate failure depends entirely on our response to challenges that have echoed across space and time since intelligence first emerged from cosmic darkness. The test continues, stakes remain absolute, and the answer lies not within distant stars but within ourselves and the choices we make in these critical moments that will echo throughout eternity. In cosmic silence that surrounds us, we find both our greatest fear and our ultimate purpose. Whether consciousness breaks free from cycles that have claimed countless civilizations or joins the great quiet between stars depends on wisdom, courage, and cooperation we demonstrate in the years ahead. The universe holds its breath, waiting for our answer to questions that have haunted intelligence since time began. Our cosmic moment's weight becomes even more profound when considering how various filters might interact and compound each other in ways we're only beginning comprehending. We're not confronting these challenges in isolation, but as interconnected risk webs that could create cascading failures beyond anything our species has ever encountered. Visualize the delicate equilibrium we're attempting, maintaining currently. We're trying developing artificial intelligence systems, powerful enough helping us solve climate transformation, while ensuring those identical systems don't become so capable they render human decision-making obsolete. We're working preventing nuclear proliferation, while managing international tensions exacerbated by climate refugees and resource scarcity. We're attempting regulating biotechnology, while racing toward developing treatments for emerging diseases that might themselves be products of our environmental disruption. Each challenge would prove difficult enough in isolation, yet they're occurring simultaneously, creating feedback loops and interaction effects multiplying their danger exponentially. Climate transformation increases political instability, which raises nuclear conflict risks. Nuclear tensions make international AI safety cooperation more difficult. Uncontrolled AI development could lead toward autonomous weapons systems, making nuclear warfare more likely. Biotechnology developed addressing climate-related health challenges could provide tools for creating devastating pandemics. This risk convergence might explain why the Great Filter appears so effective, eliminating technological civilizations. It's not that any single challenge proves insurmountable, but that multiple existential risks emerging simultaneously create perfect storms, overwhelming even highly capable species. This convergence timing appears remarkably consistent across different technological development trajectories. Identical innovations making civilizations detectable from space mice radio technology, nuclear power, space travel also provide foundations for developing mass destruction weapons, environmental manipulation capabilities, and artificial intelligence. There seems to be narrow windows where species become visible to external observers, yet haven't developed wisdom managing their dangerous new capabilities safely. We might be living within this window currently, broadcasting our presence to the galaxy, while simultaneously developing tools that could destroy us. Every radio signal we've transmitted, every spacecraft launched, every satellite deployed has made us more detectable to hypothetical alien observers. Yet we've also spent identical decades building nuclear arsenals, altering our climate, and creating increasingly sophisticated AI systems whose behaviors we don't fully understand. If advanced civilizations are watching us, they might be observing familiar tragedies. Another species achieving technological capability faster than developing technological wisdom. They might have witnessed identical patterns playing out countless times across the galaxy. Each promising young civilization following identical trajectories from emergence to extinction. The possibility we're being observed adds another dimension to our cosmic predicament. The dark forest hypothesis suggests revealing our location could attract hostile civilization attention that eliminates potential competitors before they become threats. Yet there's an even more chilling possibility. What if advanced aliens simply watch newly emerged civilizations, knowing intervention proves unnecessary because the Great Filter will eliminate us without external assistance? From their perspectives, we might resemble children playing with dynamite, dangerous to ourselves, yet not threatening to others. They could afford waiting and watching, knowing species at our development level almost invariably destroy themselves before becoming capable of interstellar expansion. Our extinction would prove so predictable that intervention would be pointless. This scenario transforms our current situation, from tests we might pass to death sentences we're unknowingly executing. Every nuclear weapon we build, every warming degree we cause, every AI system we deploy without adequate safety measures brings us closer to fulfilling predictions that advanced civilizations have witnessed, confirmed thousands of times before. Perhaps the most disturbing aspect of this possibility involves motivation not by malice but compassion. Advanced civilizations successfully navigating their own great filters might have learned that intervention in other species' development typically makes situations worse rather than better. They might have discovered technological wisdom cannot be taught or imposed externally, but must be earned through direct existential risk experience. The very act of providing help might undermine psychological and institutional development species' need for long-term survival. Like helicopter parents preventing their children from learning essential life skills, advanced aliens might have learned that rescuing younger civilizations from their own mistakes dooms them to repeating those mistakes on even larger scales later. This could explain why CT searches find only silence despite apparent abundance of potentially habitable worlds. The galaxy might overflow with advanced civilizations maintaining strict non-interference policies, watching younger species struggle with identical challenges they once faced while knowing premature assistance would ultimately prove counterproductive. From these perspectives, our cosmic isolation isn't evidence that intelligence proves rare, but proof it requires earning through surviving challenges that cannot be circumvented or externally resolved. Space silence might constitute tough love forms, as advanced civilizations providing space we need to either develop genuine wisdom or eliminate ourselves trying. This interpretation places enormous responsibility on our current generation. We're not merely making decisions about human welfare, but potentially demonstrating to watching galaxies whether intelligence deserves surviving and spreading throughout cosmos. Every choice we make about managing existential risks becomes statements about consciousness itself's maturity and wisdom. The psychological pressure of this responsibility could itself become part of great filter mechanisms. Species becoming aware of their cosmic significance might become paralyzed by their situation's weight, unable making decisive progress on any challenge because they're overwhelmed by involved stakes. Alternatively, they might become reckless, taking enormous risks in attempts proving their worthiness that end up destroying them instead. Finding right balances between cosmic ambition and practical caution might be among the most difficult aspects of navigating the Great Filter successfully. We need maintaining sufficient humility, recognizing our limitations while preserving enough confidence, tackling challenges that would paralyze less ambitious species. We need thinking on cosmic timescales while making decisions based on immediate human needs and constraints. This balancing act becomes even more complex considering the role consciousness itself plays determining our fate. Identical self-awareness allowing us recognizing existential risks also creates psychological burdens that might make those risks more difficult addressing effectively. Consider how knowledge of our cosmic situation affects human motivation and behavior. Previous generations could work toward long-term goals with assumptions that human civilization would continue indefinitely. They built institutions, created artistic works, and pursued scientific knowledge with confidence that future generations would benefit from their efforts. Yet we're the first generation in human history possessing detailed scientific knowledge about multiple human extinction pathways. We know nuclear weapons could end civilization within hours. We understand climate transformation could make Earth uninhabitable within centuries. We're aware artificial intelligence could surpass and replace human intelligence within decades. Living with this knowledge creates unique psychological challenges our species has never faced before. How do you maintain motivation addressing long-term problems when you're uncertain whether there will be long terms? How do you invest in futures when multiple independent processes could make those futures impossible? Some people respond to existential risk awareness by becoming more committed, solving these challenges, driven by urgency preserving human civilization. Others become paralyzed by despair, feeling individual actions are meaningless against such enormous threats. Still others retreat into denial, refusing acknowledging risks too overwhelming for serious contemplation. None of these responses might prove optimal for actually navigating the Great Filter successfully. Excessive urgency can lead toward hasty decisions and poor coordination. Paralysis prevents necessary action. Denial eliminates preparation and prevention possibilities. The psychological stance required for Great Filter navigation might be something unprecedented in human experience. Informed optimism forms that acknowledge existential risks without being crushed by them, that maintain long-term commitment while accepting short-term uncertainty, that balance individual agency with collective responsibility. Developing this psychological resilience might require new education, therapy, and social support forms helping people process existential risk information without becoming dysfunctional. We might need evolving new cultural practices and philosophical frameworks providing meaning and motivation, even facing species-level uncertainty. Religious and spiritual traditions offer some models for maintaining hope and purpose facing ultimate existence and mortality questions. Yet they were developed helping individuals cope with personal death, not helping entire species cope with collective extinction. Adapting these wisdom traditions to our current cosmic situation might require theological and philosophical innovations as profound as our technological developments. The challenge becomes even greater considering different cultures and societies might develop vastly different responses to Great Filter awareness. Some might embrace technological solutions with renewed vigor, believing human ingenuity can overcome any obstacle. Others might retreat toward traditional ways of life, viewing technology as the problem rather than the solution. Still others might develop fatalistic attitudes, believing extinction is inevitable and efforts to prevent it are futile. These divergent responses could themselves become sources of conflict and instability, making international cooperation on existential risks more difficult precisely when such cooperation proves most essential. The Great Filter might test not just our technological capabilities, but our ability to maintain social cohesion and shared purpose under unprecedented psychological pressure. In this ultimate test of consciousness, we discover that survival requires more than solving technical problems or managing external threats. It demands evolving new forms of wisdom, courage, and cooperation that can function under conditions no species has ever faced before. The universe watches in profound silence as we write the next chapter in consciousness's cosmic story. Whether intelligence finally breaks free from cycles that have claimed countless civilizations or joins the great quiet between stars depends entirely on our response to challenges echoing across space and time since awareness first emerged from cosmic darkness. The test continues, stakes remain absolute, and the answer lies not in distant stars, but within ourselves and the choices we make in these critical moments that will resonate throughout eternity. We stand at the threshold between transcendence and extinction, between cosmic citizenship and cosmic irrelevance, carrying the weight of consciousness itself toward whatever destiny awaits in the vast darkness beyond. Some might become more collaborative and globally minded, recognizing that species survival requires unprecedented international coordination. Others might become more competitive and nationalistic, viewing existential risks as zero-sum competitions where only the strongest or most prepared groups will survive. These divergent responses could themselves create additional risks by undermining the global cooperation that most existential challenges require. If awareness of the Great Filter makes some societies more paranoid and aggressive while making others more cooperative and trusting, the resulting conflicts could prevent effective responses to the very challenges that Great Filter awareness was supposed to help address. Managing this response diversity might require developing new global governance forms and cultural exchange that can accommodate different worldviews while maintaining sufficient coordination addressing shared threats. We might need creating international institutions that can function even when their member nations possess fundamentally different beliefs about existential risk, nature, and severity. The complexity of these psychological and social challenges suggests the Great Filter might operate as much through consciousness as through technology, identical cognitive capabilities enabling technological development, also create existential risk awareness, and that awareness creates psychological and social dynamics that might make extinction more rather than less likely. Perhaps successful great filter navigation requires not just technological solutions to specific risks, but psychological and cultural evolution, allowing conscious beings to function effectively under existential uncertainty conditions. Species developing such capabilities might graduate to become stable cosmic civilizations, while those that don't might succumb to anxiety, despair, or conflict generated by their own mortality awareness. This perspective suggests space silence might reflect not just technological solution rarity, but the difficulty developing emotional and social maturity needed implementing those solutions effectively. The universe might overflow with civilization remains that possessed technical knowledge solving their existential challenges, but lacked wisdom and psychological resilience, applying that knowledge successfully. As we face our own great filter test, the question becomes whether humanity can develop new consciousness forms compatible with long-term survival in universes filled with existential risks. Can we learn holding hope and despair simultaneously? Can we maintain commitment to future generations while accepting uncertainty about whether those generations will exist? Can we cooperate globally while preserving thought and culture diversity, driving innovation? Answers to these questions might determine not just our survival, but whether consciousness itself represents successful cosmic adaptation or merely beautiful mistakes the universe, briefly experimented with before returning to original silence. Every mortality meditation, every international cooperation act, every choice investing in long-term projects, despite short-term uncertainty, contributes to writing intelligence's story, final chapter in our galactic corner. In quiet moments between one heartbeat and the next, between one breath and another, we carry within ourselves the entire consciousness future as we know it. This responsibility weight proves almost unbearable, yet it's also our deepest meaning and purpose source. We're not just trying surviving, we're trying proving that awareness, curiosity, and compassion deserve permanent places in cosmic order. The universe watches through our own eyes as we struggle with challenges that might have destroyed every other civilization that has ever existed. Whether we join their silence or break through to become something unprecedented in galactic history depends on choices we're making currently. In these precious moments when consciousness still flickers within vast darkness between stars, the countdown continues with each passing moment. Perhaps nowhere is this more apparent than in laboratories and research facilities, where humanity's next evolutionary leap takes shape. Currently, as you process these words, scientists worldwide push boundaries of what being human means, developing technologies that could either elevate our species to cosmic significance or become final strokes in our extinction story. Consider the pace at which we're rewriting life's fundamental code itself. CRISPR gene editing technology, barely 2 decades old, now allows researchers modifying DNA with precision that would have seemed like magic to previous generations. We're not just treating genetic diseases anymore. We're redesigning human genomes, creating enhanced immune systems, extending lifespans, and potentially even engineering radiation resistance, making interstellar travel possible. Yet each breakthrough brings us closer to capabilities that could backfire catastrophically. Identical techniques promising hereditary disease elimination also provide blueprints for creating biological weapons of unprecedented sophistication. Laboratory accidents or deliberate misuse could unleash engineered pathogens, making natural plagues look benign by comparison. Our global civilization's interconnected nature makes these risks particularly acute. Viruses engineered in single laboratories could circle the globe within weeks, transmitted by identical transportation networks enabling our technological society. Unlike natural pandemics evolving constraints preventing excessive lethality, engineered pathogens could be designed overcoming every defense mechanism. Evolution developed over billions of years. This biotechnology paradox exemplifies patterns that might be universal among developing civilizations. Tools promising transcendence also threaten annihilation. Margins between salvation and extinction narrow with each advance. We're walking tight ropes over abysses, and every forward step makes ropes thinner and falls more certain. Meanwhile, in server farms and research institutes across the globe, another revolution unfolds that might dwarf all previous technological transformations. Artificial intelligence systems evolve at exponential rates, displaying capabilities their own creators struggle understanding or predicting. Machine learning algorithms now surpass human performance in tasks from medical diagnosis to strategic planning, and gaps widen with each iteration. The trajectory remains unmistakable. Within decades, possibly years, we'll create artificial minds exceeding human intelligence in every measurable domain. These systems will be capable of recursive self-improvement, redesigning themselves faster than biological brains can comprehend their changes. The moment this threshold is crossed, human intelligence becomes obsolete, relegated to identical categories as insect or bacterial cognitive abilities. The question keeping AI researchers awake nights isn't whether this transition will occur, but whether we can maintain meaningful control over it. Programming superintelligent systems, preserving human values and interests, requires solving alignment problems we barely understand, let alone know how to implement reliably. Failure consequences aren't just human extinction, but potentially converting all matter in our light cone into forms optimized for alien computational processes. Yet we continue racing toward this precipice, driven by competitive pressures making restraint seem impossible. Nations slowing AI development risk domination by those that don't. Companies prioritizing safety over capability risk being outcompeted by those willing cutting corners. Competition logic pushes us toward identical outcomes regardless of individual preferences or collective wisdom. This dynamic might represent the great filter's cruelest aspect. Intelligent species might consistently recognize dangers they face while being unable coordinating effective responses due to identical competitive instincts, enabling their initial success. Traits allowing species surviving and dominating planetary environments might be precisely the traits preventing them surviving technological adolescence. Consider how this pattern plays out across every existential risk domain. Climate transformation requires global cooperation addressing, yet national interests make such cooperation difficult achieving. Nuclear disarmament would benefit everyone, but unilateral disarmament leaves nations vulnerable to cheaters. Biotechnology regulation needs international coordination, yet regulatory arbitrage incentivizes moving dangerous research to jurisdictions with weaker oversight. Collective action problem mathematics suggests most civilizations might face identical coordination failures, regardless of intelligence or good intentions. Game theory predicts rational actors will often make individually sensible yet collectively catastrophic choices. Prisoner's dilemma scales up to planetary proportions where stakes aren't just personal advantage, but species survival. Perhaps this explains the Great Silence more comprehensively than any specific technological threat. Every civilization might face identical fundamental challenges, transcending competitive dynamics serving them well during evolutionary development, but becoming lethal in existential technology contexts. Species that can't make this transition consistently eliminate themselves, while those that do might be so rare we've never encountered their existence evidence. The window for making this transition appears rapidly narrowing for humanity. Climate transformation accelerates beyond our most pessimistic projections. Nuclear weapons proliferate to new actors with potentially less stable command structures. Artificial intelligence development proceeds without adequate safety measures. Biotechnology capabilities expand faster than our understanding of their implications. Each day passing without catastrophic breakdown might simply mean we haven't yet encountered specific circumstance combinations triggering our filtration. Like Titanic passengers in hours before impact, we might be congratulating ourselves on smooth sailing while racing toward icebergs we can't yet perceive. The psychological toll of living with this awareness creates additional risk layers compounding our technological challenges. How do societies maintain long-term thinking necessary for species survival when individuals are overwhelmed by existential anxiety? How do democracies address challenges requiring today's sacrifices for benefits that might not materialize for generations? The next time you look up at night skies, remember you're gazing into what might be the universe's greatest cemetery. Each silent star system might once have hosted civilizations that faced identical challenges we confront today. Each empty frequency might represent another species that couldn't bridge the gap between technological power and technological wisdom. We stand at consciousness's final examination, where every choice echoes across cosmic time and every decision carries the weight of intelligence itself. The universe holds its breath, waiting for our answer to questions that have haunted awareness since time began. In this ultimate moment of testing, we discover that survival requires more than solving technical problems or managing external threats. It demands evolving new forms of wisdom, courage, and cooperation that can function under conditions no species has ever faced before. Whether consciousness finally breaks free from cycles claiming countless civilizations or joins the great quiet between stars depends entirely on our response to challenges, echoing across space and time since awareness first emerged from cosmic darkness. The test continues, stakes remain absolute, and the answer lies not in distant stars, but within ourselves and the choices we make in these critical moments that will resonate throughout eternity. Those luminous points aren't merely distant stellar furnaces, but potential monuments marking civilizations that never survived the examination we're experiencing currently. Whether humanity joins that eternal quietude or becomes something unprecedented in galactic chronicles depends on choices we're making during these precious moments when consciousness still glimmers against vast darkness. We might represent the universe's final opportunity for self-understanding, or simply its most elaborate failure. Regardless, intelligence story itself is being written through our decisions, our collaboration, and our wisdom. Confronting challenges that have halted every other species before us, the great filter awaits, and time diminishes rapidly. Each passing second brings us closer to whatever threshold awaits ahead. Whether breakthrough toward cosmic citizenship or breakdown into cosmic silence, the mathematics proves stark, given universal scale and age, plus billions of opportunities for life emergence and evolution. We should detect abundant civilization evidence. Instead, we encounter profound quietude. This silence grows more ominous with each empty radio frequency, each unsuccessful telescope survey, each night sky devoid of artificial illumination. Whether this absence reflects our ultimate isolation or ultimate test depends entirely on wisdom, courage, and cooperation we demonstrate in years ahead. Standing beneath star-filled expanses that might conceal our greatest hopes or deepest fears, we face sobering truths. We might represent not universal intelligence triumph, but merely its latest experiment in an endless series of cosmic failures. The great filter awaits somewhere many-years in our technology, our nature, or reality's fabric itself. Yet perhaps this knowledge provides our greatest advantage. Previous civilizations facing these challenges remained unaware of their cosmic solitude. We possess unique opportunities approaching our species' greatest test with complete awareness of involved stakes. Understanding the great filter's potential nature might prove key to becoming the first civilization successfully navigating beyond it. The universe observes silently as we compose intelligence's next chapter. Whether that chapter concludes in triumph or tragedy depends on choices we make in coming decades. Choices echoing across space and time, determining whether consciousness discovers its permanent place among stars or joins the great silence surrounding us. In cosmic silence enveloping us, we find both our greatest fear and ultimate purpose. Whether consciousness breaks free from cycles claiming countless civilizations or becomes another cautionary tale scattered across void depends on responses we provide to questions haunting intelligence since time began. This represents our species' defining moment, not merely survival, but transcendence of complexity traps, coordination failures, and technological dangers that have claimed every other civilization reaching our development level. Success requires unprecedented wisdom, cooperation, and long-term thinking. Failure means joining cosmic silence. The examination continues, stakes remain ultimate, and answers lie not within distant stars, but within ourselves. Whether intelligence finally establishes permanent cosmic presence or remains forever trapped within great silence surrounding us depends entirely on our next steps forward into uncertain yet momentous futures. As we stand at this threshold between transcendence and extinction, between cosmic citizenship and cosmic irrelevance, we carry within ourselves the entire weight of consciousness's survival across vast scales of space and time. The great filter challenges us not merely to survive, but to prove that awareness, curiosity, and compassion deserve eternal places within cosmic order. The countdown continues with each heartbeat, each breath, each moment of choice carrying implications extending far beyond human welfare toward consciousness's ultimate destiny throughout the cosmos. In these critical years ahead, we write not just human history, but potentially the only story consciousness will ever tell. The universe holds its breath, waiting for our answer to the darkness between worlds. Whether we illuminate that darkness with permanent light of intelligence or fade into silence like countless civilizations before us depends on wisdom we demonstrate, cooperation we achieve, and courage we summon in, facing the ultimate test of conscious existence. Time grows short, challenges mount, and the great filter awaits our response. In the end, we discover that consciousness's survival depends not on distant technologies or external forces, but on our capacity for wisdom, unity, and hope in the face of unprecedented challenges that will determine whether intelligence has a future among the stars or becomes merely another beautiful failure in the cosmic laboratory of existence. The final examination of consciousness unfolds now, with every choice resonating across eternity and every decision carrying the weight of intelligence itself toward whatever destiny awaits in the vast darkness beyond.